Hello and welcome back students to the next module of the chapter where we'll be once again doing sums based on enthalpy of chemical changes. Let's take the sum. Question says, calculate the standard enthalpy of formation of benzene from the following data. That means if you see the equation carefully, the overall delta H is been given to you and delta H of formation of carbon dioxide and delta H of formation of water is given to you. So let's quickly write the given data. The first thing which is given is the overall delta H, which has already been mentioned. Second is enthalpy of formation of carbon dioxide is given and enthalpy of formation of water is also given. And we have been told to calculate standard enthalpy of formation of benzene, that means the delta H, not for formation of something called as benzene, that is C6H6. So the various formulas which we can use are this, but since it is a reaction, we'll be using the third formula, that is summation of enthalpies of product minus summation of enthalpies of reactant. So let's do the sum which is there. Now the first thing which we have to write is writing the formula in terms of equation. So it is enthalpies of product minus the enthalpies of reactant. The products which are mentioned are 6 carbon dioxide and 3 times water. So writing that in that terms, we get 6 times the enthalpy of formation of carbon dioxide plus 3 times the enthalpy of formation of water minus of reactants, that is 1 time the formation of something called as benzene, and if we directly open the bracket, we'll get minus 15 by 2 times the enthalpy of formation of oxygen. Now, the overall equation's enthalpy, that is delta H, is given to us as minus 3267 kilojoules. So minus 3267 is equal to 6 times enthalpy of carbon dioxide, that is minus 393.5 plus 3 times the value of minus 285.8 minus enthalpy of formation of benzene we have to calculate, and minus its 0. Why? Because it is enthalpy of an element in its standard state, so its value has to be taken as 0. So the value remains as minus 3267 is equal to minus 2361 minus 857.4 and minus enthalpy of formation of benzene. So the thing which we have to calculate, that is enthalpy of formation of benzene, we take it on the left hand side, and minus 3267 term we bring it on this side. So we get the answer as delta H of formation of benzene is equal to minus 2361 minus 857.4 and plus 3267. Making the additions and the subtractions, we'll get the final answer as 48.6 kilojoule. So this is how the sum has to be solved. Let's quickly go through certain MCQs. The first question says, calculate the standard enthalpy of formation of ethane from the following data. If you see the equations carefully, the overall delta H is been given to you and the delta H of formation of carbon dioxide and water is also given, and using this data we have to find the appropriate answer. So let's quickly do the sum. The formula will be enthalpies of product minus enthalpies of reactant, since it is a reaction. The products which are mentioned are 4 times carbon dioxide and 6 times water. So taking that value, delta H is equal to its 4 times the value of carbon dioxide plus 6 times the value of water minus 2 times the enthalpy of ethane minus 7 times the enthalpy of oxygen. Now the overall delta H has been given as minus 3119. 4 times the value of carbon dioxide, that is 4 times minus 393.5 plus 6 times minus 285.8 and minus 2 times the enthalpy of formation of ethane, and minus it will be 0. Why? Because oxygen is present in the elemental form. Its value has to be taken as 0. So it is minus 3319. It is minus 1574 minus 1714.8 and it is minus 2 times the value of enthalpy of formation of ethane. So once again, the things which we have to find, we keep it on left hand side, and rest everything we bring on the right hand side. We get the answer of enthalpy of value of enthalpy of propane as minus 1574 minus 1714.8 and it is plus 3119. Doing additions and subtractions, we get the final answer as minus 169.8, and using this we think that the option is D. But wait students, we have got the answer as 2 times the value. Whereas in the question it says enthalpy of formation, that means for only one single mole which is there. So dividing the equation or dividing the answer by 2, we get the final answer as option C, that is minus 84.9 kilojoules. So this is how this particular question has to be solved. Let's go to the second question, which says that 38.55 kilojoules of heat is absorbed when 6 grams of oxygen reacts with ClF according to the following equation. And there is some equation given, and we have been told calculate what is the standard enthalpy of this reaction. Means we have to calculate for this particular reaction the enthalpy change. That means we have to calculate the answer for either 2 times the answer of ClF, or 1 mole of oxygen, or 1 mole of Cl2O2, or 1 mole of OF2. Now since in the question it has been mentioned that 38.55 kilojoules of heat is absorbed when 6 grams of oxygen reacts. That means we have to take into considerations the number of moles of oxygen. And can I say 1 mole of oxygen is 32 grams? Whereas in the question it says 38.55 kilojoules of heat is absorbed when 6 grams of oxygen is reacting. That means whenever there is 6 grams, this much amount of energy is reacting. Therefore 32 grams, the value will be X. Simple cross multiplying the answer, will get the answer as option B, that is 205.6 kilojoules. We meet in the next module. Till that time, thank you.